In this section, we're going to move on from parallelograms and their areas to areas of trapezoids, rhombuses or rhombi, and kites. The important thing that we want to recognize is that in a trapezoid, the height is the perpendicular distance between the two bases. So that is the height, and we would call this base 1, base 2. Also a reminder that in a trapezoid, the mid segment is B1 plus B2 divided by 2. So the area of a trapezoid is equal to 1/2 the product of the height and the sum of the lengths of the bases. Okay? Well, I don't need that right now. Or I can just think of this. Now I can rewrite this as H times B1 plus B2 over 2. Well, if you look at the top there, I can say H is area of trapezoid is H times the mid segment. So even if you're not given the two bases, given the mid segment, you can find the area of the trapezoid, and which is kind of neat. And the mid segment is a segment that connects the midpoints of two legs of trapezoid. Let's label that leg and leg, and when the legs are congruent, you have an isosceles trapezoid. So here we go, and this is a really lovely diagram up here which shows you the trapezoid. Maybe I would write this as B subscript 1 plus B subscript 2. I don't want that should be that, should be that, just a small typo there. A little review: in a kite and a rhombus, the diagonals intersect at angles, and in a rhombus, since it's a parallelogram, the diagonals bisect each other. So a little review given along the way. In a kite, the longer diagonal will bisect the shorter diagonal, and you can prove the two small triangles to be congruent to each other. So area of a trapezoid is half the height times the sum of the lengths of the bases of half the height times the mid segment. The area of the rhombus can be found by just multiplying the diagonals and dividing 2. I want to remind you that when you have a right triangle, you may use the Pythagorean theorem to calculate half the diagonal length. So for example, if you were given this is 5 and you were given then this is 4, you could find this x and x and x would be congruent. So you could find this 4, this 4. You could find x using Pythagorean theorem, and you could find both d1 and d2 and find the area of the rhombus that way. The area of a kite is just, the formula is the same as that for a rhombus. This is a right angle, this is bisected. Okay, now here this is a little different. The longer diagonal is not bisected. However, if you had enough information, you can still use Pythagorean theorem. Okay, there's some very interesting problems here. So here's a lovely little chest, and you want to find the area of the front in the shape of a trapezoid. So this is a straightforward application of the formula. Okay, rhombus, the diagonals are bisected, so I'm just going to remind you of that fact here. And this, the 3 and the 6, so you can find the hypotenuse here. Do we need that? No, actually we don't need the hypotenuse here, but if you were asked to find the side for any reason, you could use Pythagorean theorem to do that. Yes? Okay, number one diagonal of a kite is 1/3 as long as the other. So this is the way you start out. Say, let diagonal 1 have a length of x meters. Then diagonal 2 is 1/3 as long as the other one. So that's 1/3 x meters. Okay? And you can take it from there. So area is half d1, d2, then go ahead and put it in. I want to remind you that x times x is x squared. X plus x is 2x. So ask yourself whether you're multiplying or dividing when you solve this problem. Okay, recognize another trapezoid. And the reason I know this is a trapezoid is because these two RS and UT are horizontal lines. Their slope is 0, and when two lines have the same or equal slope, they are parallel. So these are parallel. And I want you to pay attention to the scale. I'm just looking at the scale, and in the horizontal scale, 1 unit is, or 1 square is 5 units. So you may want to go along the whole square, count the number, multiply that by 5 to get the true length, and to get the true height also. And when I say the true length, I mean the length of segment UT and segment segment UT and segment RS, because those are the two bases. So I would further label this as height B1, B2, and go further. The part that needs attention in this problem is the scale on the x and y axis. So be vigilant about that when you're trying to solve a problem. And I guess that is the end. So good luck with that.